Cool. Thanks a lot, Solomon, for organizing this, and Mohammed for inviting me. I really appreciate it with you guys. So yeah, today I'm going to be showing you guys almost primarily a live demo of actually deploying and managing Hyperledger Fabric on real public clouds across multiple geographies. But to give you...
If you want to swing around the table.
Yes, I am a prolific pacer, as you may have noticed over there, so this presented a slight challenge to them. But yeah, okay. Cool, yeah, so I figured before I show you the live demo, I want to afford you a little bit of... There's plenty of power. Yeah, cool. I want to afford you a little bit of context, so I made a very brief PowerPoint. It's only 7 slides, 2 of which are the opening slide and the thank you slide, which leaves 5 slides left of actual content, so it'll be quick, and we'll get to the real demo, which you guys want to see. So, I work for Cloudsoft, and as a great disclaimer in the beginning, neither myself nor Cloudsoft claim to be blockchain experts. Our bread and butter is application deployment and management. And it just so happens that we work on Hyperledger Fabric as an application that we deploy and manage across its lifecycle. We have a team all over across Europe, primarily in Europe. Actually, our headquarters are in Edinburgh, Scotland, which is lovely this time of year. Once winter kind of gets behind you, it's smooth sailing until like September. I would go in August to the Fringe Festival, which is a big performance art festival. Great time to go. I happened to schedule my visit to HQ in August. That's just a coincidence though, so it's very nice. Cloudsoft is the founder of the Apache Brooklyn open source project. And Apache Brooklyn is a key name to remember because it's the heart and soul of everything I'm going to be showing you today. We are the primary contributors to this open source platform, and Cloudsoft AMP, which stands for Application Management Platform, is our enterprise offering of this open source project. Everything that I show you today can be achieved on this completely free open source product, but I'm just going to be showing it to you using our enterprise product with a better UI, additional features, things like that, but it all can be done completely for free. I'm just going to show you a slightly enhanced version. And basically it's, well, let's get the last one. Cool. So the idea of Cloudsoft AMP and Apache Brooklyn, by extension, is to model, deploy, and manage applications. We model applications by building blueprints that describe what they are. By a show of hands, is anyone here familiar with Docker Compose, or what a Docker Compose file might look like? Okay, a few people. Cool. So basically, Docker Compose is a YAML, so it's basically a human-readable file that just describes components. And our blueprints are not terribly dissimilar to Docker Compose files. For those of you that means something to you, then excellent. Otherwise, it's basically just a YAML markup language that describes how applications, like the components in applications, which components depend on other ones, so you know the order in which to deploy them, and things like that. Then we actually handle the deployment of these applications onto a wide range of targets, public clouds, private, on-premise, bare metal, all these kinds of things. The next slide should show that. And we handle the deployment, so you don't really have to care about, once you have a blueprint, you don't have to care about where it goes. It's location agnostic. We're handling that for you, which we think is a big value add. And finally, we help manage the applications through their life cycle. So it's not just fire and forget, it's fire and remember and manage. Right, so this slide is just describing what I said to you previously. We have a blueprint, and that blueprint can be deployed to a bunch of different kinds of applications. The author of the blueprint doesn't care about where it's going when you write it. You just, at deploy time, give it somewhere. I believe there's a fancy animation that our CEO did. Yes. Okay, cool. The blueprint can go anywhere. Isn't that awesome? This complicated slide, we can go over pretty quickly. It actually relates to what Mohammed said at the end about the idea of sensors and effectors. So basically, Brooklyn and AMP provide sensors for every application that gets deployed. Now these sensors are relatively specific to the application that's being deployed. There are built-in sort of standard fare sensors for everything, like the IP addresses of the individual components. They're pretty binary healthiness check, are they good or are they on fire kind of thing. But then there's very specific sensors for applications. If you've got, I don't know, let's say you have a database being deployed by AMP, there might be a sensor that tells you the rate of requests or the load on it or how much space is being used on the data, things like that. It's specific to the application. There are specific sensors that make sense that you want to know about, provided by the blueprint. And then there are effectors that can actually affect change on the application. And the idea of the autonomics comes in. What this is basically showing is that given sensor values, take effector actions. So an example would be that, let's say you have a cluster of something that has a sensor value saying, what are the requests per second? Effectively, what's the load on this cluster? If it's above a certain threshold, okay, you better spin up more nodes and make the cluster bigger. That's the effector, increase the size. On the other side of the coin, let's say if you're being underutilized and you don't want to waste money by having too many resources, you can scale down if it's under some floor. Live demo time. See? That wasn't lying, it's quick. So let's get to this in action. Okay. Cool. So right here is Cloudsoft AMP, our main product. The AMP server is running on my local machine. That's the only thing that's going to be local about what I'm showing you today. Everything else is going to be on real cloud infrastructure. But the AMP server itself, the orchestrator, you might think, happens to be running on my machine because I didn't want to have any risk of it being slightly slower for a demo, things like that. But everything else is deployed on real clouds. AMP itself obviously can run on any VM or anywhere, but I didn't feel like sacrificing something to demo gods today. I just figured running my local machine is the easiest. So let's go to the app dashboard. These are 5 applications that I have deployed with AMP onto real locations. Is that probably pretty hard to see? So let's make it bigger. Okay, so basically what we're looking at is, and I'll go into each of these in minor detail, but I can just go over them very briefly right now. You see 5 of them. One is a Hyperledger Fabric cluster, which is just basically Hyperledger Fabric running in one location, the one cloud endpoint. We also have a Hyperledger Fabric multi-cluster, which is a really cool one, which is actually Fabric running multiple clusters of validating peers on different clouds. We'll actually expand it soon, but it's running on IBM Bluemix, AWS, Azure, and Google Container Engine, GCE. It's running on all of those, and they're all talking to each other, and it's a real Fabric cluster. Now, I want to stop for just a second. By a show of hands, we're doing more show of hands questions. I know we already had to do it a few times, but how many of you here, either personally or maybe overseeing a coworker, let's say, have actually created a Fabric cluster for yourselves and have actually played with it a little bit? Sweet, okay. I'm going to guess the way you did that was probably on your local machine with all the Docker images also running on your machine. Is that correct? Okay, cool. That is the standard fair way of running this admittedly pre-production software. You're going to run it on your own machine. It's not yet really being run anywhere in production because we're all here, we're all bleeding edge. But what we're doing here is we're actually not just doing some, run Docker containers on a local machine and say, hey, look what I've got. We're running it on real clouds across the world. So we're saying that sure, Hyperledger Fabric right now isn't necessarily there yet, but it's possible, and you can do it with us, and we'll grow as Fabric grows. So we're doing it in a more realistic way, more modeling what production will be like in the future. So right, Hyperledger Fabric cluster, the multi-cluster, which is the cool one. I'll come back to that. It's a surprise guest. I didn't even tell Mohammed about it. It's exciting. But also, how many of you here are familiar with Kubernetes? Is that a word? Cool. So for those of you who are not, Kubernetes is a let's call it a container management engine. If that's not exactly the right way to say it, I apologize, but it's Google's open source container management engine. It's pretty much the most popular, the hottest one. It is generally, I think, more used at this point than Mesos, which I guess you might call its main competitor. Anyway, it's the thing you should be using if you want to be using a container management engine, in my company's opinion, and therefore must be mine. Kidding. So, although I also do think that. Right, we have Kubernetes. So 2 weeks when I was in Scotland in August, this particular year, it wasn't actually like just drinking the whole time and not doing any work. We actually, I had to go there and work with the Kubernetes expert in our company to build a blueprint to stand up a Kubernetes cluster. And we were, how would I be politically? We were somewhat disappointed in the quality and consistency of the documentation for how Kubernetes could be stood up. So we basically had to say, all right, this is a hard task. Standing up Kubernetes yourself is not easy. So we made a blueprint to be able to do it, and to be able to do it on all of the major clouds, which we think is pretty cool. So AMP has stood up a real Kubernetes cluster, and then we've deployed Hyperledger Fabric onto Kubernetes. Not just using Docker daemons, we've actually deployed it against Kubernetes fully functioning. I'll show you that too. Done a lot of cool stuff that may or may not mean anything. So let's show you, let's get into the weeds a little bit. So the idea of that AMP can, so blueprinting, you can blueprint your applications. you can deploy them, and then you can manage them. So I'll actually show you a live model of each of these really running. And just to pause for one moment, I like to use a metaphor from programming, which may help some people and may not. The idea of a class versus an object. Does that distinction mean something to people here? Do you guys show hands? Right, so briefly, basically, the class is like the code that you're writing. You're basically describing something, how it's going to run. And then an object is like a living, breathing instance of that. So basically, these blueprints are kind of like classes in the object-oriented world. And then the actually running applications that AMP deploys are like the objects, the instances that are actually running. So I'm going to show you a live look at the model of the real applications running. So let's go to the simplest one right now, the Hyperledger Fabric cluster that's running, I believe this is running on AWS. And I can check to make sure. Okay, sorry, it's actually running on, I deployed it against IBM Bluemix in San Jose. So this is actually running there, and I will show you, just to start off with proof, I will show you that in fact, it's small. In fact, so this is a look at the Bluemix UI. These are a bunch of VMs that are actually running in Bluemix, and these were all deployed by Cloudsoft AMP. But we can see them in our own window here. So I'm now going to be going into the live model and actually expanding this and showing you the components of Hyperledger Fabric cluster that are running. And anyone here who's familiar with Hyperledger Fabric's specifics will recognize everything you see here. There should be no surprises here. And that's basically a validating peer cluster consisting of validating peers, specifically Docker hosts running. So these are 1, 2, 3, these are 4 VMs running with Docker installed, and then on each of them is a validating peer container that comes from Docker Hub that Hyperledger has published, running a validating peer node. So this is modeling to you a live container that is actually running on Bluemix. So we'll just expand this for the sake of showing everything. Okay, so cool. That doesn't need a ton. So let's go take a look at the sensors that I mentioned earlier of any of these nodes. So we might take a look at, okay, here's some basic information about that. Don't worry about, so what you're seeing for people in the back is basically some of the basic stuff, like the IP, the health, whether it's running, the IP address of this container, things like that. Or I guess the host, actually, that's running the container, to be specific. So just for one more proof that this is very real, so we'll take this IP address, which is one of the Docker hosts running the Hyperledger Fabric container, and we'll go over to SJC, and I'll paste it, and I'll search it, and there it is. That is, in fact, the VM running that component that AMP knows about and is managing. Cool. Okay, that's a basic cluster on one location. I would say that's moderately cooler than just installing Docker on your work computer, pulling down 4 containers, all the peers running on the same computer, and saying, hey, look, I have Fabric running. Now we're actually running it against a real cloud on multiple VMs. But let's do something cooler. Let's actually deploy it against a bunch of different clouds. Here's the moneymaker, right? Here, the screen's a little bit, if the resolution were higher, you'd see these expanded names. But we have a validating peer cluster on AWS, on Bluemix San Jose, on Bluemix Singapore, on Azure, and Google Container Engine. And to show you how the root node actually knows about all of these, I will go to the root. I will go to an effector, which is basically, like I said, something that you can take action. And I will actually do the list peers command. For any of you familiar with Hyperledger Fabric's admittedly now deprecated REST API, moving to 1.0, because this is a 0.6 cluster, again, for some specifics. Our blueprint is also evolving to support 1.0. Anyway, I will show you all the peers that it knows about, and these are across all the different clouds. Pretty cool. And it's just running right now, making the call, and it will, of course, allow me to stall and just boom, there we go. Cool. So it will go to standard out, and this, it's text. Basically what I'm showing you is, these are a bunch of validating peers, each with the IP addresses of those nodes. Now if we took the time to go back into the sensors and looked at each of the peers, we would in fact see those IP addresses there. And if I went into each of these windows here, Bluemix, Azure, AWS, Google, we would search it, we'd see all the addresses are there. They're really running, they're really talking to each other. And that is across the thing. And so basically, the idea is to attach more meaning to this. The idea is that this is trying to simulate the idea of multiple banks or multiple organizations all contributing components to the blockchain, contributing validators to the blockchain. Now, some of you are possibly thinking, and if you're not, then I'll tell you a smart thing to think, is that, well, wait a minute, blockchain's supposed to be distributed. This looks like a single point of control. Like, well, what's going on here? That's very true. This is sort of a proof of concept right now. But the idea is that this would evolve into each of these. So let's say instead of public clouds, that each of these were different banks or different whomevers, whatevers, and they want to contribute to a blockchain cluster together. They could use a part of this blueprint, targeting some known membership services node or some known route that an agreed upon trusted party is hosting, and they can just stand up their component of it. And right now, basically, this is sort of like God mode, or whatever you want to say mode, where I'm starting them all to show that it's possible, because it's just me right now. But these are all like different parties contributing some resources. Like the bank of AWS, let's say, will have 2 validating peer nodes that are contributing to the overall. 2 in each. That's why we saw 10 in that list of peers before. Cool. Okay. I also want to show you a couple of cool things. For those of you familiar with Kubernetes, there are a couple hands. We also have a version of our blueprint to deploy Hyperledger Fabric against a Kubernetes cluster. So we can see here, this is getting a little specific into how Kubernetes works. I'm just going to cut to the chase and show you, hey, cool, look, this is a real Kubernetes dashboard running on AWS with all the components that those familiar with Hyperledger Fabric will recognize. A bunch of validating peers, a membership services node, and a CLI node. Very cool, running against Kubernetes. Just another way, basically giving you another option to deploy this. So now, smooth transition. Before, you guys were asked, why start from scratch? Fantastic question, Fabric Composer, fantastic question. But I do have a good answer for you. It's 3 days before you're doing a keynote in beautiful Broomfield, Colorado at DFRAG, I believe was the conference. And your CEO tells you, cool, you can stand all this stuff up. That's not cool enough. I want a real demo. I want something running. There's no Fabric Composer at this point. This is several months before it became available. So I had to start from scratch, and I had to write myself a basic blockchain application, which I want to show you running now against this global network. So basically, I myself did what now Fabric Composer, which was just shown to you before, can make really easy. I had to basically write myself I learned Go, or at least I learned enough Go to be able to do this, and then I wrote a blockchain application against a chain code that was provided by the Fabric repository, and which was like an asset management demo. I built myself a REST API, which again can be generated by Fabric Composer. And give me a second, this will work more. And I basically said, okay, I made a REST API to list the assets owned by an owner and then transfer them. So basically, I'm just going to show you for the sake of, that you know this cluster is real. That these 3 owners, Charlie, Dave, and Edwina. And Edwina is a sort of a strange British name, perhaps. I had never heard of it, but we're a UK-based company, and my CEO said to name the E character Edwina, and I didn't argue with him because I love having a job. So, yeah, basically, this is just printing out a bunch of assets, which we're familiar with the idea that blockchain can hold assets. It's just these are a bunch of different famous art pieces. I think they came from the David Bowie auction that art he owned. And each of these 3 owners basically own these assets, and you can transfer them between it. I'm not going to go too much more into this because we already saw a whole good demonstration of a real working application that Fabric Composer built. But the surprise guest was, and this is actually kind of cool, the surprise guest was that I have one other, let me go back to the app dashboard. The one I didn't talk about was an HLF cluster with Fabric Composer. So this is an experimental branch on my fork. Read might not work, but it did actually work for this demo. And basically, this is me standing up another Fabric cluster on a real cloud provider, and then also creating another VM, installing the Fabric Composer command line interface, taking the demo application the demo asset management application that they offer, that's usually the first getting started thing, and actually deploying it against the Fabric cluster that we've stood up. And then it generates the REST API and actually creates, I think you talked about this in the abstract, the loopback API Explorer. So this is actually a live API that is running against the cluster that I stood up. And if you want to mess around with it, if someone wants to go to an arbitrary IP address because you trust makes that like a nice space or something, you can go to 161.202.25.248:3000/explorer and actually play with the getting started application that Fabric Composer that offers. And you can see, like, for example, different assets that exist in this. I believe it's a land registry asset management demo, so you can actually try it out. And you can see that, oh, there's 2 pieces of land, a small flat in the city, a nice house in the country. You can trade them, and you guys can actually, right now, if you really wanted to, you could manipulate the state of the blockchain that I have here. I've made it open, like, there's no permissions for the sake of this demo, and you can just mess around with it. So I can leave that running for a day or two. I'll probably get yelled at for using up our cloud resources. So, like, I don't know. If you want to mess around with that, you absolutely can. But yeah, so I think the takeaways of this perhaps fairly technical discussion was that with Cloudsoft AMP, you can model, deploy, manage like pretty much any application you'd like if you blueprint it. And we, of course, offer a catalog of blueprints. And then once it's running, you can manage it through its lifecycle. An example of this is Hyperledger Fabric that we deploy and manage. And I showed it to you against a bunch of different real cloud providers, linked them together. And then this is just an inside look at what I'd like to create as a collaboration with Fabric Composer to make it really easy to stand up real Fabric on some real infrastructure and make it easy. So if you want to develop a blockchain application easily with Composer, you probably also want to actually try running it somewhere beyond just, oh, it works on my machine, like, you know, 4 Docker images. This is where it ties together. And we both Fabric Composer and we at Cloudsoft are going to be moving into supporting 1.0, which is still moving. It's a fairly quick moving target, if I understand correctly. But that's coming in the coming months. Sorry if that was a whirlwind, and I think we're nearing the end of time, so if you want to throw up any softball questions for me that I can knock out of the park, I'd like that.
That's very interesting. Okay, I'm a YAML using deploying different clouds. Supposing I have a Fabric already deployed,
Yeah.
can I use it and one into it or manage it up?
As of right now, you can't hook into an existing one right now. It has to be something that we have deployed for you. So admittedly, at this point, no, you have to kind of go through the whole steps with us. I am not sure roadmap-wise when we would necessarily do that, but it totally makes sense. And if it's something that people are asking for more, then it might be something we would do to hook into an existing one. Because it doesn't seem like it would be particularly hard. But right now, the answer is no. Yeah, fair enough.
Great presentation. I liked it. I had one question, like the mapping between nodes and like Fabric Composer concepts.
Yeah.
You know, there is a distinction, right? And in your case, are you handling like certificates, identities, keys? How are you determining in terms of autonomy?
Right. Okay. So as I mentioned, so are you familiar with Hyperledger Fabric, the 0.6 version? Right. So 0.6 was not exactly the most, I'll say it, robust with security. So basically, what we're doing is we have a. I'll answer that by easier to show than tell. Sorry, just 1 second. Okay. So we have a membership services node, right? And the membership services node publishes a pretty standard list of keys that clients can sign in as. So we're not really doing anything more than just using the keys that come standard with the Fabric repository, and these nodes sign in using those keys. So it's not particularly secure in that sense, of course, but we're pretty much just working with what 0.6 has to offer, which is more in the proof of concept.
So my question was more like, even in the roadmap, right? Even 1.5 as an intermediary, somebody handling the DevOps side of things, you know, how much would I have to trust you, you know, with the keys and certificates? That's a challenge I think you guys have to answer.
Yeah, no, that's true. I guess I'm not sure exactly to what extent you'd be trusting Cloudsoft AMP. I think it wouldn't ultimately be that much, because the idea is that we are ultimately going to be creators of infrastructure for you, where you point, if you're using public clouds, let's say. Creators of infrastructure, pullers of Docker images, and then networking together. So I think you're really not trusting us with particularly much other than standing up. Like, I think it will come down to how secure the functionality of the images are. Not a great answer, and the reason is because I'm not that familiar with 1.0 yet, and that's a hard question I'm gonna have to try to solve.
Can I chime in there?
So sure.
Are you asking about the certificate part of the member services and how that's managed?
Not particularly how Hyperledger does it, but when you have an automation like this one, right? does the membership service have to recognize the tool itself as yet another node? Or,
Okay.
that's, I think, an important thing, right? That comes down to it.
I do not, okay, still not rock solid answer, but I do not believe that, so none of these components right now know about AMP, and I don't think that in the future they would have to either. All AMP really has to know about is effectively where are these things running, where can the AMP be able to effectively SSH into and pull and get sensor information. And
Essentially, you're utilizing the container management.
so can you start from the beginning?
You're essentially using the container management facilities to hook onto your AMP, like either the Docker or Kubernetes, so that you can find out what is happening within the.
Yeah, I think so. Right now, basically, we're to give you the health checks on these. We're basically, I think doing like I forget exactly what I wrote, like some kind of Docker PS where I'm checking the is running state and making sure things are working. Yeah, pretty much just using like standard ways of checking health like that, and then
Will you
getting.
be able to go more into the fabric design within it? Like, for example, what transactions are there can also be seen from here?
Okay, so
Like what the features and composite?
Yeah.
We can save some of those questions, so.
just to, I think I answered pretty briefly. So to rephrase to make sure I understand, and also repeat to everyone, you're saying how much management of what is running on the fabric are we offering right now? Little right now. That's also we are giving you a look at the cluster itself running, but an absolute to do for us is to have more deploying to it, right? So once we've stood it up, actually manage what is deployed on the fabric, not just the fabric itself. So yes, so right now I guess the answer is not really, we're not really showing you beyond the stood up cluster itself, but absolutely one of the most important things you want to do going forward is manage what's on it.
Fabric is very modular and customizable. A lot of it's pluggable. For example, go to the membership services, you can use the default tooling, whatever they have to give out certificates, or you could tie it into an authentication process you have within your network already. You get to choose whatever database. There's CouchDB. There's a lot of. It's very modular. You get to plug this, plug that, plug this, or incorporate as many processes as you already have within your business already. That's one point I wanted to mention. Secondly, there was a question earlier that was asked that I didn't understand. Excuse me, miss, what's your name? She's on her laptop. Yeah, I said I wanted to go back to a question you asked earlier because I didn't understand it as well. I think I do now. So what he was able to show with the Loopback API Explorer is when Fabric is launched and I set up the playground, I do all the administrative work, the users access it through the Loopback API. Do you mind if I? So,
Still won't let me do that.
so. And this is the network that he created. His example is different from mine, but let's say with my example, you'd have something, you'd have the assets, which was vehicle listing, you'd have your participants, and the other people in your organization would use the tool. They'd go here and they would make the commands simply from here. They would do a post or they would do a get on the assets. And this is the, as it is today, this is how they would interface with the application without having to start from zero. You've already set the properties, right? So in this example, if he were to post a land property network, he would, using this format, insert the information there, and if he wants to do the get function, the get call on the same asset, he would use get and it would pull back the particular information in the call. So is that more clear of how you set it up with the composer and then give everyone else on the network access? You later on the blue?
Can I just clarify, see if I can clarify what you're saying a
Let's
little bit
take
more?
one.
Okay.
Is that, like,
Zaccardo.
you're provided this API, right? And a developer could build some sort of front end, right? Like, that looks like a car auctioning
Yes.
site, right? And then your users would just use that front end and say, I want to auction my car, just like any old normal website.
Mhm.
And then the front end itself is going to be hitting those APIs. It's going to be doing those things,
Yeah, yeah.
right? That's, so I just want to.
You should be up here next time. Presentation. Wonderful. Exactly. So you set it up with the Fabric UI, get all the development stuff. You set the network, the permissions, all of that. Based on the permissions that he said, if you go to this asset, you're able to only do what you're allowed to do. Kind of like how I said it. And the users only interface with this. You make a command, you pull. Fair enough?
All right, so I
I'm
think
done now.
we'll, yeah, all right, thanks again. Obviously,